Welcome to geometry. And today we're going to be talking about the distance formula. How do I find the distance between 2 points? How do I find the distance of the sides of a triangle? So in this case, we have triangle A, A, B, C. We have triangle ABC. And I want to find the distance of AB, AC, and BC. How do I do that? Well, in the coordinate plane, I know that I can only move left, right, up, or down. In this case, to get from B to C, I need to trace right 4 units, right? And I need to trace upwards 7 units, okay? But what I'm really interested in is how do I get this distance right here? How do I find this piece? That's really what I'm interested in, okay? And so how do I do that? Well, maybe you guys remember that formula from Pythagorean theorem before, because in this case, I've drawn myself a right triangle. Here's a right triangle. One of the sides measures 4, one is 7, and the other is, I don't know, it's x, right? So this is what I have here. I have this idea where this is a right triangle. This is 4, 7, and x. Okay, well, how do I find x? Remember this formula that said a squared plus b squared is equal to c squared? Well, that's what we're going to use. In this case, we're going to say, well, A, this is the general form of the triangle. Okay, you have side A, side B, and side C. This is always the hypotenuse. Okay, so we're saying, okay, well, in this case, A is, and you can always switch these two, okay? These two can always be switched. You can always have A or B switched, but C has to always be the longest side, the side across from the right angle. That is always C. So in this case, we're going to say, well, A is 4, so 4 squared plus what's B? B is 7 squared, and I'm looking for C. Okay, that's what I'm looking for. So, okay, so 16 plus 49 is equal to C squared. Okay, and then I do 16 plus 49. I get 5 and 6, right? 65 is equal to C squared. Okay, well, I want to solve for C, so the last thing I do is to undo the square, I do square root and the square root. So that means that C is equal to the square root of 65. And I'm done. So this means that C is the square root of 65. Not sure exactly how much that measures, but I know that it's the square root of 65, and I can type that in my calculator and get an actual number. Okay, so if I want to do this using the distance formula, okay, using the distance formula is using the coordinate points. So let's find the distance between B and C. First, you gotta tell me what the coordinates of B is. So B is 3, -1, and C is 7, comma 6. Okay, C is 7, comma 6. And now I need to find the coordinates, the distance formula. Well, the distance formula says this. Well, if I have 2 points, I have x2 minus x1 squared plus y2 minus y1 squared. That is equal to the distance of any segment. Okay, that's equal to the distance of any segment. Well, what is x1 and what is x2, y1 and y2? Well, this is the x1 coordinate. This is the y1 coordinate. This is the x2 coordinate. This is the y2 coordinate. Okay? Remember that we got radical 65 for the distance already. So we're trying to see if we're going to get the same thing again. So x2 is going to be 7 minus 3. And that's going to be squared. And we have plus y2 is 6. Y1 is negative 1. So minus a negative 1, that becomes a plus. Okay? And that's squared. And don't forget to square root everything. Okay? Well, what's 7 minus 3? 7 minus 3 is 4 squared plus, but 6 plus 1, 7 squared. And don't forget, this is all square rooted. And so what does this equal? Well, 4 squared plus 7 squared, I end up with the square root of 16 plus 49. And here we go. This is equal to 65. Okay, that's how you use the distance formula in an example. So I got the distance formula here, right? When you have a triangle in the coordinate plane, you may just use the Pythagorean theorem. But when you only have coordinates such as B and C, then you need to be using this formula, okay? You have to be using this procedure. This is the distance formula. Now I want you to practice using the distance formula in this example. You try it, okay? Well, what is the distance between these 2 points? Remember, this is x1, this is y1. This is x2, this is y2. Okay? Now here is another triangle, and you want to find that to show that the triangle is isosceles. Remember, what does isosceles mean? What does this mean? Well, it's a triangle that has 2 sides being equal. So you want to find the distance of these 3 sides such that 2 of them are equal, okay? You got to show me that 2 of the sides are equal. So find the distance of AB, right? If I have a triangle called ABC, what is the distance of, what's the distance of AB, right? What's X, what's Y, what's Z? You're going to find that 2 of these distances are going to be the same. And that's all I want you to do. If you have any questions, please feel free to use the app or send me an email. See you tomorrow in class.